it's going to be Charles Williams and developing VBA add-ins. Now, because we've overrun slightly on the last one, I'm not going to play the charity video here. We're going to go straight into the session in a second. But before I do, I'm just going to explain a bit about Charles. Charles and I've known Charles for quite a long time now. I've been lucky enough to wander around Seattle with him a few times, and he lives in a part of the world I used to live in, actually, Leamington Spa. So I presume he's still there. He's an independent Excel consultant for over 20 years. He's fanatical about Excel performance and extensibility, and I cannot emphasize that enough. He's developed C++, XLLs, and VBA add-ins and solutions, and he's currently dabbling with JavaScript. He's the author of the FastExcel, SpeedTools multi-threaded function library, Manager Pro, and Name Manager add-ins, and he's been an MVP since 2009, and well-deserved it is. So I'm making it sound like all the others aren't I? That's not what I mean at all. So his session here is developing the VBA add-ins, and it's targeted at people with some experience with VBA who want to learn how to create more professional XLLs add-ins for Windows. Charles, I think, is around. So what we're going to do is we're going to get Sam to actually play the video. I think we'll go in there. No charity video this time, Sam. I think we're just going to go straight into it.
Hi everybody, I'm Charles Williams, and this session is about building VBA add-ins, which is something I've done a lot of. Now what we're going to cover is what are XLLs add-ins, why would you want to build them, and how do you do it. And I'm going to be using developing an add-in example, the function lister. What this does is to look at all the functions that are being used on whatever the active worksheet is and produce a listing of them along with how many are in use. Then we're going to talk about how you protect add-ins from curious eyes or against inadvertent meddling with, how you distribute them, and how you install them. So, why do we want to do XLLs add-ins? I think the primary reason for me is that it allows you to overcome what is one of the primary limitations of VBA. If you put VBA in a workbook and you start sending it around to people to use, very soon you're totally out of control. You've got millions of different workbooks all around the place. You've got no sensible way of updating them. You know, it's a real mess. If you put all your code in an XLLs add-in, then you can keep that separate from the data in the workbook. And you can put that in one place, so you can simplify sharing and deploying it. You can put it on a network share or SharePoint or somewhere. And that way it's much easier to update. You've only got the code in one place. Rather get side benefits of XLLs add-ins. You can restrict access to the VBA code. You can make better VBA UDFs. It's easier for users to get at because you just have a ribbon. It looks like it's part of Excel, and they operate at application level rather than workbook level. So they're available to whatever workbooks you have open. What are they? Well, they're just a special type of hidden workbook. It can contain ribbon XML, so you can have your own bit of ribbon for the add-in. They can contain VBA, they usually do, and they've got some hidden worksheets. And these are useful things because you can use them to store formatting that you can use for formatting templates, formatting reports, and so on. And you can also store any data that the XLLs add-in itself needs. It tends to be fairly static data. And they're usually installed using the Excel add-in manager. So we'll look at that too. So how do you do it? Well, I'm going to demonstrate building the function lister add-in. As I said, it shows the list of all the functions used on the active worksheet. A word of warning, this is demonstration code to keep life simple. It's not production level. It doesn't have very much error trapping, and it doesn't do a few things that you'd want to do if you were trying to make this professional. Okay, now I'm going to develop this function lister add-in in stages. And stage one is the first step is to find all the unique formulas on the active sheet, rather than then once we've got the formulas we can find the functions within the formulas. So we've got to use R1C1 mode rather than A1 formula mode, because otherwise all the relative references look different. So you make a formula that contains a relative reference, you copy it down, that's basically the same formula really, but in A1 mode it all looks different. So we're going to use R1C1 mode to get around that. We're going to use a scripting dictionary to store all the unique formulas and count them. So let's look at the VBA. So we start by pressing Alt F11, and here is the VBE, the Visual Basic Editor. Now the first thing I want to do is to show the debug toolbar. So we go to View, Toolbars, and let's show the debug toolbar, because we're going to be using this a lot, and I'm not going to explain all the options on it yet. We'll do them one by one as we come to it. Over on the left I've got the Project Explorer that shows me everything I've got open and allows me to switch between various bits of the project. Now, okay, at the top I've got Option Explicit. This means that I have to declare all the variables with dim statements and so on before using them, otherwise I'll get an error. This is just basic good practice. Make sure we don't misspell a variable and not catch it. Option base 1 means that all the arrays that I declare start with 1. That's for compatibility with XL. XL basically starts everything with 1. But other products like the dictionary object that we're going to use sometimes starts with 0 instead. So we have to be a bit careful about that. Option compare text means that whenever I'm doing a comparison between two bits of text, it's always going to compare them in uppercase basically. Okay, now my first sub is called listfuncstart. It declares dict formulas as a dictionary. So to do that, to make that work, I've got to make a reference to the scripting dictionary. So you can see here we've got Microsoft scripting runtime has been checked. If you don't do that, you'll get a compile error. At the moment this should compile. If I go up to debug, yeah, there's nothing there to compile. The compiler is grayed out saying it's already been compiled. So we set the dict formulas to nothing, not strictly speaking necessary, but I like to do that. And then I create a new dictionary object called dict formulas. This dictionary is going to hold key value pairs. The key is going to be the actual formula itself, and the value is going to be the number of times that formula appears on the sheet. Then I pass this this dictionary to my get unique formulas subroutine. So how does this work? Well, first thing we've got to do, I don't want to look at the whole sheet looking for formulas. This could be very inefficient. So what I'm going to do is find the last non-empty row and column, and then restrict myself to looking for formulas within that. So if I've got a a huge used range, I'm not going to waste time looking through all millions of blank cells. To avoid errors, if we start this on an empty sheet, it doesn't work. So we use this little VBA snippet to find the number of rows and the number of columns in the active sheet. Set it to a minimum of 2 cells, and then set a range to be the A1 on the sheet expanded by the number of rows and the number of columns. Then I get the R1C1 version of the formulas in the whatever the local language happens to be. So if I'm in France, I'd get the French version of the formulas. If I'm in Italy, I'd get the Italian version of the formulas. I'm in England, so I'm getting the English version of the formulas. But hey, there we go. The Formula 2 was introduced with dynamic array version of XL, which is what I'm using, and gives me the dynamic array version of the formulas rather than, it gets rid of those silly little @ signs that tend to appear on the front of things. So I'm getting all the formulas within that expanded version of A1 into V formulas. And let's put a little breakpoint here, click there, and then we run that. First of all, I gotta go and activate the test data sheet. Okay, then I'm going to come back to the VBA. When we look at the test data sheet, we will see that, yeah, I've got a formula, very simple formula. It's copied down. So if I look at that, look at the actual formulas, you can see that they're all different in A1 mode, but in R1, C1 mode, they're all going to be the same. Okay, so now we go back to the Visual Basic environment, and we're going to start that running by clicking this nice little green button, or I could use F5. Boom. Okay, so now we've stopped at this point. Where we're at is highlighted in yellow, and let's see, using the locals window, what that V formulas variant variable actually contains. Well, yeah, it's got some headers there, and then you can see we're in R1 C1 mode. It's picked up the formulas in R1 C1 mode, and yeah, the second row of these formulas is the same as the first row, so that's basically working. Now, looking at things in the locals window is a good trick. You can see exactly what's happening in the VBA. With my J and K, I've got 21 rows and 4 columns, and I'm on 0 and 0 for the loop. So now I'm going to loop through all the things in the V formulas array. I'm going to loop on the rows and then on the columns, and I'm going to skip empty cells because, hey, I don't want to analyze those. So if the length of the formulas is greater than 0, we're going to look at them. But we're only going to look at them if they've got an equal sign on the front, because otherwise they're a constant, so they're not going to be a formula. Then the dictionary object has got a nice little thing called exists that allows you to check whether that thing, the key, actually exists in the dictionary. Let's step through this one by one. So the first, tell you what, let's put another breakpoint there. And we'll put a breakpoint there, and let's scroll through until we get to the point where we've actually got a formula. And this is the second row and the second column has got a formula. It's the first row in the data, first column on the test data sheet is actually data. So then this it doesn't exist. This is the first instance of the formula, so we'll add it to the dictionary, and we'll add 1 as the count of that formula because it's the first occurrence, and we can go on like that. Let's skip to the end of the subroutine. We'll click the breakpoints off and go to there. Now you see these debug print statements I've got there. That's putting stuff out to the immediate window, and I can click that, and we can see all the formulas that have been put into the dictionary. And you can see here we've got the count. So the debug print statement says show the formula, then a little blank to set as a separator, and then the actual value of the item value of that corresponds to that key. So you can see the first time it's a 1, the second time we get that formula, it just increments the count to a 2. Okay, so that's done. The dictionary has created the unique, picked up all the unique formulas associated with their count. So the next thing we've got to do is to look at those formulas and parse out the functions that exist in each of the formulas. In this case, there's only going to be 2. Okay, because it's a very, very simple example. But when you've got a more complex worksheet with several thousand rows and columns and stuff, and a lot of different functions, it's quite useful to see what functions are actually being used. So we'll close that. We'll go back to the list funcs 1. We'll close that. No, I don't want to save it. And then I'm going to open list funcs 2, which is the next stage. Okay, so what we're going to do here is to scan each of the unique formulas that we've built up in this dictionary, scan them for functions. So how do we do that? Well, the rules for functions are a function must be a function name immediately followed by an open parenthesis. And function names follow rules. The first character must be either an alphabetic character or an underscore or a backslash. And the next characters can be either alphabetic or underscore or decimal point, full stop, or 0 to 9. And by the way, we want to ignore function names that occur inside quotes, quoted strings, square brackets like you get in tables and so on, and curly brackets like you get in array constants. Because hey, they're not really formulas, they're not really functions. So then once we found a function, we want to store each unique function name and account in a dictionary object in a very similar way to the way we did it for the formulas themselves. Go back to the VBA. We'll close that immediate window. Okay, so this is version 2 of listfuncs. Now, okay, we've got a bit more complicated stuff here. The way Excel works is different language versions of Excel use different things for curly brackets and for list separators and so on. And also, of course, you can have you can be using Excel with Cyrillic characters or Greek characters, or it's not just Latin characters, or they might have more accented characters than can be handled in the standard Windows code page. So instead of using something like the VBA like statement, I could say is like A to Z. That wouldn't work with with anything other than the standard Latin characters. So we've got to use this Windows API call. And so what we do is the one we're going to use is char alpha. That works with all the Unicode characters. And so we have to pass it the Unicode number of the character, and it will return 1 if it is an alphabetic character, 0 if it's not. Now we've got to do a conditional compile here because we don't know whether we're going to be running this in 64-bit XL or 32-bit XL. So if #if VBA7 says if we're running in 64-bit XL, use this version of the function call, which is pointer safe, and that basically switches pointers from being 32-bit pointers to 64-bit pointers. and if it's not VBA 7, not 64-bit, we can use this the standard long. Okay, so that's the conditional compile. The list func start routine is pretty much the same as it was before, except that now I've got to run the initialize routine to get the different versions of the curly brackets and list separator. So the initialize routine just says it uses application.international to get whatever is the current version of XL that's being used, is using for the left brace, left curly bracket, right curly bracket, and the list separator, which is usually comma or a semicolon. So that just gets them into these module level variables, and then I can use them throughout all the rest of the routines. Then okay, we do the dict funcs and dict formulas, and like we did in the version 1, but we also do a very similar thing for dict funcs, which is going to contain the functions themselves and their count in a similar way to the formulas did. So the first thing we do is get all the unique formulas. Then if we found any unique formulas, we'll go and get the functions out of the formulas. So we pass the unique sheet funcs subroutine, the formulas, and dict funcs dictionaries. And we're going to get all the unique function names and their counts. So first thing we've got to do is assign some variables, dimension some variables. I'm using switches here so that if BL single Q is true, then we're within a single quoted string, double Q if we're currently within a double quoted string, and squares we're within square brackets, and curlies within the curly brackets, and so on. Then we loop on every single formula within the formula dictionary, and we get the formula count, which we stored as the value for that key. Then within that we're going to look for the function name. So what we're going to do is to loop character by character through the formula, and we're going to exclude quoted strings. So let's put a breakpoint there, and let's run func start. Okay, so now we've got to the first bit of checking whether this character is to be excluded or not. So if we go through to that function, stepping through thing by thing. So what we're doing is checking one by one if the character we're passed through, as we hover over it, is an equal sign. So it's not going to be a single quote, it's not going to be a double quote, it's not going to be a left square bracket, it's not going to be a right square bracket, it's not going to be a curly, so we return false. Okay, so we can see what that's been doing. Let's switch off that breakpoint. So let's go look at how this goes and parses out the function name. So it's going to, okay, I don't want to go through that character and excluded part again, so now I can use this function to step out. Control Shift F8 instead. Click that, and we will keep running. I'll step out of that, back in there. Okay, so the character we've got to is an open bracket, and it's actually the 5th character in this formula. So now we've got to look backwards to see whether all the characters before this open brackets are open parenthesis are valid to be a function. They could just be some kind of operator or another bracket or something or other. So this function finds the function name before the open parenthesis. So we loop backwards towards the start of the formula, and we get the character. So let's go through there. So the first character is M. Okay, sounds good. And yeah, so that's an alphabetic character. So it's a so we're building up the name of the function by adding it to fname. Let's have a look at the locals window. Okay, so we can see that I'm currently building up the name of this function character by character, and when I finally get to something that isn't it's either the first character because it's a backslash, or it's not a function name character, then we've got the complete function name. If of course none of them are, if it isn't really a function name, we'll be returning a blank. So let's skip ahead, undo that breakpoint, skip to the end. Okay, we found some. That is definitely a function name. So now we return to the, it is a function. The name of the function is more than one. It's a function, so we can add it to the function dictionary. So this is the same kind of code as we had when finding the formula. We find out whether it exists. If it is, instead of adding 1, we add the formula count. Now there are 20 occurrences of this formula because we covered it all the way down. And so we're going to add 20 if it exists, and we're going to add the 20 and the name of the function if it doesn't exist. Okay, so that will bars out all the functions and their counts. Whoops. Okay, that's the next function name, SUMIFs. Run to the end, and let's see, we don't want to see the locals window. Again, we've been using debug print to print out to the immediate window what's been happening. Okay, we can see, so we've got firstly that was put out from this bit here was put out from the first routine, and this routine has put out 20 being the count of the function's sum, and 20 being the function of SUMIFs. So that all looks like it's working fine. Great. Let's move on to the step 3. So we'll close that. We'll keep that one open, it's the test code, and we'll close listfuncs 2, and we'll open listfuncs 3. Okay, so now we've got to generate the report. We've found all the unique functions and their counts. We want to add a worksheet to the whatever the active workbook is, and we're going to produce a formatted report on that worksheet. So here we're using formats within the add-in itself. Okay, at the moment, perhaps I should say that I'm still working in an XLSM function. I haven't yet converted it to an add-in, and that's generally speaking the way I work. The last step in creating an add-in is to actually convert the XLSM file to an XLAM file, and we'll come to that later. Okay, so here we're storing the formats that we want to use for this report within the add-in. It's within the add-in itself, and we're going to use those to format the report. Okay, let's go back to the test data and use a slightly more complicated set of formulas rather than just those two. We'll go to the VBA, Alt F11, and see what we've done differently. Well, the first bit's all exactly the same. We get all the unique formulas, we get the unique functions, and if we've got more than one function, then we run the show list routine. So this starts by creating an addition. Well, we grab the sheet name for whatever the active sheet is, and then we create a new sheet within the active workbook. First thing we do is to loop through and see how many existing sheets we've got, because you might well want to run this add-in multiple times for all the sheets or several of the sheets within the active workbook. So we don't want the report to overwrite itself, so it's going to produce a set of report sheets which are going to be the function list and a number. The first one's going to be 1 and so on. So we start by counting how many we've already got, then we increment the number by 1, and we create a new sheet, and using the name of the list sheet and whatever the number is. Now, how do we refer to this workbook, which has got all the VBA code in it, as distinct to whatever the active workbook is? Well, funnily enough, you just use this workbook. So this workbook.worksheets func_list formats, that's that range that's got all the formatting I want to use. So I copy that and I paste it into the new report sheet I've just created, A1 to F3, and I append on the top cell A1. I add in the name of the active sheet, so it's easier to see in retrospect which one we've actually created the data for. Now we get the data into the from the function dictionaries into a couple of variant arrays. First one gets the keys, which are the formulas, which are the function names, and the second one is the counts, which is the items. Now, okay, I've got a stop statement here. When I run this, it's going to stop at that statement, and we can look at the locals. Could have put just a breakpoint, but it's interesting to just demonstrate another technique, which is to use the stop. Okay, so we want to get rid of the immediate window and look at the local window, which is that one. And let's look at the names of the functions. Yeah, I've got quite a lot of different function names in here. But notice over here on the right, this vfunc names is a variant array, but it's 0 to 9. It doesn't start with 1. Because the arrays from the function dictionary are 0-based, not 1-based. Ouch. So I can't put them directly back into the sheet because I want them to be going down the sheet, and if I just put in this one-dimensional array, it's going to go across the sheet. So what I've got to do is transpose them, so that will create something that will then go. I can put back on the sheet, and I can put them back on the sheet in one go, which is much more efficient than looping through them one by one. So we'll put those onto the sheet, we'll auto fit them to make it look nice, and we'll put out a quick little message to the user at the end. Okay, right, 10 functions found on sheet tests, and this is the report sheet it's created. Let's go back to Excel to see it. Okay, function name, formula text, reverse text, sum, x lookup. this funny one. Okay, that proves my Windows API call is working. That's Boris in Cyrillic, and it's actually a Lambda function. And okay, I've got all these other things with their counts. Wow, so this is all looks pretty good. This is working. Okay, good. Let's look at the tests thing. You can see that's the Boris formula, and it actually occurs 3 times in the same function. Well, now that we've got all that working, it's time for the final step. We've got to turn it into an XLAM add-in. Right, so first thing we do is let's close off listfuncs 3 and let's open up listfuncs 4. Yeah, okay. So we've got to add a user interface because we haven't really had one up till now. We've just been running the subroutines and the stuff directly from within the VBE. And when it's an add-in, we don't want to do that. We want to have a nice little entry on the ribbon for the user to use, and we'll add a hotkey as well so that when they're hopping around from worksheet to worksheet, they can just use the hotkey to list all the functions on it. Then we've got to convert it to an add-in. So let's protect the VBA code, and we'll talk a little bit about that. Save it as an XLAM, install it as an add-in. There's various ways of doing that, so we'll cover a couple. And then finally, yeah, we probably ought to do some testing because I haven't done a lot of that so far. Okay, so let's start by opening up the Office Ribbon X editor, which is a free add-in which I use to edit the XML. So we want to open up listfuncs 4, and yeah, I've already put the ribbon XML code in there. It's fairly simple stuff. If you look at this, so we say ribbon tabs, we add an extra tab which is going to appear as list functions, and it's going to put it after the add-ins tab. Then we add a group which is called list function add-in, and this is very simple. It's only got one button on it, and with a label list used functions, screen tip, list all the functions that are being used. The image that we're going to use for this is one of the images that already exists within the Office platform. I'm choosing Pivot Formulas menu. It looks more or less like the right kind of thing for what we're doing. We want to make it a large size, and when you click it, it's going to run this subroutine in the add-in. We can validate that. Yeah, looks good. We can show what the callback looks like that we have to put in the VBA code. So it looks like this. So you can see this is blist function action, and within that we will say something like run the starting routine. Okay, so let's see if that's actually done what we expect it to. So yeah, look up here, we've got list functions, and yeah, and look, we've got a button we can use, and when we hover over it, we get the tooltip. Yeah, it's not a brilliant icon. We could make our own and use that instead. So let's look at the code we've got. So you can see here I've added the ribbon callback, and it just calls listfunc start. Actually, a few minor modifications in here. Doesn't work on if you've got a protected structure, so etc. Right, and that's fine. So that's when we press the button, the icon button on the ribbon, it'll run through that, it'll start that, and away we go. To make add the hotkey, you've got to add something in somewhere. I chose to put it in the workbook open event, so that the hotkey will be applied whenever the add-in is opened. and so it runs the list func start routine whenever you press Control Alt Shift F. That's what that combination of characters does. And when the workbook's closed or unloaded, we switch that off just by calling it without any routine to call. So we can see that if I switch back to the test data workbook, I've got function list 1. If I press Control Alt Shift F, bang, it's generated function 2. Or I could test, I don't know, let's pick that one instead. And right, I can't call it from the ribbon at this point because the ribbon only belongs to when it's an XLSM, the ribbon only belongs to the workbook that it's in, and I'm not in that workbook at the moment. It only appears when I go back to list func 4. Then it's there. As soon as I switch to another workbook, it disappears. When we make it into an add-in, an XLAM, that restriction disappears. It becomes an application level ribbon rather than a workbook level ribbon. Okay, so let's go back to the Visual Basic code. Right, so we've added the hotkey, we've added the ribbon, we've added the calling function from the ribbon. Next trick is to protect the VBA. So we go to Tools, VBA Project Properties, add in a project description, function list add-in, and go to Protection. We want to lock the project for viewing, and we want to add a password. Well, I'm going to call it PW. Not a very serious password, we could use a better one, but I might remember that. Okay, and so now we've done all that. The other thing actually that's a good thing to do is to put some descriptions in the properties, advanced properties of the workbook. So I want to put a title in and add some comments. The reason for this is these are the things that appear when we're using the Excel add-in loader. Okay, which we'll look at next. Okay, so we go back to that. Now we want to save this workbook as an XLAM. So it's just a different type of workbook, XLAM. Now, for some reason, Excel decides at this point it wants to change the directory to app data roaming Microsoft add-ins. I don't want to do that. I want to put it myself where I want it to go. So I don't want to go there. I want to go to Excel Virtually Global, and I want to call it list funcs for XLAM. So then I can save it there, and now I've got a copy of it saved as an XLAM. So I can close this, and then first thing I can do is if I open the XLAM file, bang, it's there. If I go back to the VBE, yeah, it's there as an XLAM. When I click it, it's asking me for the password. So I could unlock it, but I'm not going to. The point is here. Now I've got the ribbon is actually showing, and it's all password protected. So if I go there, yep, I'll add another functions list sheet. So that works if you just open the XLAM, you get a temporary copy of the XLAM loaded into this instance of Excel. if I close Excel completely and then reopen it, it won't load up the my functional list XLAM. It's not there. Not there. Definitely not there. So what we've got to do here is use the add-in manager, the Excel add-in manager, to make it permanently load, if that's what you want to do. Now, I tend to do this from the developer tab, which is not the standard one that that appears. So you might want to go to Options, Customize Ribbon, and then you can check the developer tab and have it show up. There are various kinds of add-ins. The kind we're dealing with is an Excel add-ins. So I click that, and for some reason this is rather slow. It's actually looking around in the registry to find all the stuff. There are various add-ins I could load, and the one I have to browse to find the one I want, which again it points me at this ridiculous place. Instead we want to go to the right place, and we'll choose listfuncts for XLAM and the function list add-in. You can see here it's now showing properly the whatever we put in the comments for the workbook. Click OK. That will load the, see the list functions appears. We've got it. It's all good. So if we close Excel again and reopen it, got to be the right version of Excel. Oh, complicated machine this. You can see it's opening another add-in there, and yeah, so this time the list functions add-in automatically appears every time Excel is loaded. So there's two choices there. That's the way you can do it. Now the Excel add-in manager is actually making an entry in the registry, and sometimes with add-ins you need to unscramble when Excel gets itself in a mess in the registry. So I'll just show you how that works. We go to the registry editor, regedit. Yeah, I do want to make it change to the register. And in version 16 of Excel options, here we have, let's move that over a bit. We can see I've got two entries for add-ins. First one it opens is the Manager Pro add-in, and the second one it opens is my list functs for XLAM. So this registry key is created by Excel when Excel closes after you've gone through the add-in manager. You can delete it, and the add-in entry will not be there next time you open Excel. Of course, you get open 1, open 2, open 3, and so on, the more add-ins you have, and they have to be in that sequence. Of course, to make a really polished, fully professional add-in, you need to do a bit more than I've shown you so far. I actually use a whole set more tools for my professional add-ins. We've shown you the Office Ribbon X editor. That's the link to go and get it. It's free. On the protection front, just putting a VBA password in there doesn't make it very secure. There's a product called Unviewable Plus, which does a better job of making your add-in unviewable. Again, it's not foolproof. A determined person can always get through that. For installing it, I actually use a proper installer. Setup Factory is the one I use. Again, you can get it from Indigo Rose, and that simplifies the installation for the end users. I create proper help text for my add-ins, and I use Helpsmith. I use Helpsmith because you can create both NetHelp, so you can load it up to the web and just point to it from within the XL add-in, and that makes it simpler to use from both Windows and Mac and so on. It'll also do more conventional help like CHM files and so on. And then finally, for VBA itself, I use the excellent MZ Tools product, which is a suite of tools built into the editor. Fantastic. Okay, so that's all I have time for. Thanks for watching this. Hope you enjoyed it and learnt one or two things. Great. Bye.
Thanks very much, Charles. And yes, that was very informative. I always feel a bit guilty talking to Charles about videos here with VBA, because I know he knows about 1,000,000 times more than I ever will. But I think we have Charles joining us live from Leamington, where I think it's 10 to 8. Is that right, Charles? Are you about?
Yeah. It's 8 minutes to 8, I think.
8 minutes to 8, so we've got to sorry. But we've got me on camera today. Poor everybody, because it's 8 minutes to 6 in the afternoon here. So I'm sort of ready to go and still in the office here, which apparently we're on the 8th floor. So here we've got about the floodwater. But thank you for joining us here. Now, we don't seem to have had any questions in the Q&A, but that doesn't get you off the hook, Charles, because we've got a couple of questions, but it's all right. We've already prompted him. So, Charles, you already know the sorts of questions I'm going to ask you, and thank you very much for that informative session going through. The first one I've got to ask you is, given Power Automate, JavaScript, Power Query, Office scripts, what do you see as the future of VBA?
Well, I think that's a great question, and it's quite a hard one to answer. The proper answer, I think, is that it's still horses for courses. Some things are better done with VBA, some things are better done with Power Query. In fact, I mean, if you can use Power Query to automate the getting and transformation of data, it's a better way of doing it in general than VBA. Unless, of course, you run into Power Query performance issues, you might want to switch back to using VBA. The Office scripts looks like a great tool for the future, because it's the only way of automating things really that runs across all platforms. For VBA, you're restricted to Windows and Mac, and if you want to run something in the cloud, tough. VBA ain't going to do it. But on the other hand, VBA is still probably the most powerful of all these techniques. It's got better coverage of all the things that Excel can do, and probably always will do on the desktop, because there are some things on the desktop that are just different to, like getting at the file system and so on, that are different to things you can do on the web. And so I think there'll always be a place for VBA, but it is a very old technology, and it would be great if Office scripts in particular got as powerful as VBA and could do all the things that you want to do with VBA. It'll do them a bit slower than VBA, but hey, most of the time that doesn't really matter. So, you know, the answer is it depends what you want to do.
No, okay. But you see a long fulfilling future still for VBA out there?
Yeah, I think so. You know, apart from anything else, I mean, you've got a lot of enterprises around the world whose lives depend on VBA, and it's going to take a long time to, if at all, to ever migrate stuff to JavaScript or whatever. I mean, for instance, my commercial products in total are about, I don't know, 150,000 lines of code. You know, the thought of having to rewrite that in JavaScript, yuck, I don't want to do that.
No. I would have wanted to write it in the first place, Charles.
Yeah.
No. Yeah, no, it's look, Charles is very highly regarded against Microsoft with the stuff he does, and if you aren't aware of it, I do strongly suggest you check out his websites and all the things he's got. He's got some very great stuff in there, and therefore I think it'd be remiss if I didn't ask my other question, Charles, which is, what's your favourite VBA trick?
Ah, wow, that's a hard one. I think the best trick is using VBA in conjunction with named ranges. So if you want to get data out of Excel into VBA, which is something you've got to do most of the time, you can use a named range and then access that from VBA, and then whenever somebody messes around with the workbook and adds extra rows or moves stuff around, your VBA still works. Wow, magic.
Yes. Yes. As a model auditor, I can tell you how many times that's broken, and I'm sure how many times you've fixed other people's code. That one, so I can desperately concur. But that probably helps you with your fees, doesn't it, going through each year? So,
Great.
Conscious. I mean, it seems. I feel very bad given it's not even 8 o'clock over there, and we're almost at the last session. Before you go, what would be your final advice for people going into VBA and things like this? So if that's me, I go, I don't know, but you're the guru here. What will be your biggest tip for people there?
Well, I think that's a tough one to answer, actually. It's taken me 20 to 25 years to learn what little I know about VBA, and every year I learn more. So there's a lot of stuff. The great thing about VBA is there's an awful lot of stuff out there on the web, and you can Google your way to an answer to just about anything, and that's really the answer, I reckon. Google is still much better than the Microsoft documentation. Probably always will be.
My lips are sealed. Somebody once asked me in terms of how do you become an MVP, and I said, be faster at Googling things than everybody else. That's no. Look, I'm very grateful for you coming on, Charles. We appreciate you coming back. You have been the it's between you and John Peltier as to the MVP that has been on the most of these events. I think you have been in some shape or form on I think 6 out of 8, if I've got it right. Well, we look forward to welcoming you back next year if you come. We may even do a physical one. I don't know, but next time in the UK, I'll definitely come and see you for sure.
Yeah, absolutely.
No, thank you for your time. And look, do check out. So, Charles, do you want to give me contact details and website just to finish off, and so people can go and check you out?
Well, yeah, I'm at decisionmodels.com as a website. That's the Excel calculation site. It's got a pile of information about how Excel does all its calculations, and it also links to my FastExcel products and stuff like that. And then I've got a blog, the FastExcel blog, that has got a ton of articles on how to make things run faster, because that's my other thing I spend my life doing, as well as VBA.
Excellent. Yes, and you must check out some of that stuff, because Charles is the person that Microsoft go to find out what's the fastest way of doing things. So you must go and have a look. Charles, it's been a blast as always. Thank you very much. We all know that I'm right at the other end of the spectrum when it comes to VBA. I know how to spell it and not much more. We would welcome all the people that are either watching this live or later to actually please give your feedback. It's always useful, so everybody knows what they can come back with next year. You saw Victor in the last one got inspired for what he's going to come back with next time. Here's the QR code, or use the bit.ly link, bit.ly/EVG 2022 feedback. Make sure it's case sensitive there. Well, it is case sensitive. You can't make sure of that, but make sure you put it in right. Otherwise, Charles, once again, thank you very much for being one of our sort of most regular MVPs on this. I kindly appreciate you taking the time. I also appreciate you coming on. So thanks very much.
Thanks, Liam. Cheers.
Cheers. Bye bye.